Hello everyone, Glitch here, and today we are going to talk about the release of a new extension that I've been developing for the past several weeks and excited to release it. It's WealthLab Deep Learning, and we have Cone and VK here along with me, and I'm going to take them through it. And I thought since I'm going to take them through it and help me find any last remaining glitches in this thing, I'll just record it and present it as the walkthrough video for WealthLab Deep Learning. So we all know how prevalent machine learning is becoming in our world, and I have to say I used ChatGPT quite a bit, even developing this, helping me learn the intricacies of a lot of these types of neural networks and libraries and things like that. So it's about time that we get a extension that is leveraging some of these concepts. It's in the extensions menu, WealthLab Deep Learning. The basic thing here is this extension is also extendable. So we have a concept here of learning engines. So this thing will be able to support multiple learning engines. So you see here, I have a bunch of models that I created, and we come with 3 learning engines out of the box, but we offer an API. So we, or even third-party developers, maybe Dr. Koch or others, can build their own learning engines to plug into this tool. So I think that's pretty interesting, and that's something new for WealthLab. I mean, we had NeuroLab, which this is kind of replacing. We never had the capability of plugging in different neural net engines, into this thing.
Very cool.
Yeah.
So how does it work? So we've got models here. You create a model, and then you train your model, then you evaluate the results, and then you use it as an indicator in WealthLab. So let's go through a quick test here. So let's click the new button and create a new model. We're just going to see if we can create a model that is capable of learning something. And we're going to try to have it learn the day of the week. So based on today's day of the week, let's have this model learn tomorrow's day of the week. That should be pretty simple, right? So these are the 3 learning engines that we have in deep learning. We have NCOG, which is a C# neural network engine that was developed, I think, in the mid-2000s. We have Torch Sharp, which is a .NET wrapper for the Torch library, which is a library of neural network and tensor, manipulations, that is what the very popular Python PyTorch uses. So we're using the same library as PyTorch. And then I have a Torch Sharp LSTM, which stands for long short-term memory. It's like a more complex type of model that uses like a whole sequence of data to try to predict future values. So this is what we come with, but these are all extendable. So I'm just going to pick NCOG here. And so now we have our new day of the week model, and we notice here that we have inputs. So the way this works is just like in NeuroLab, you'll be able to drag in different indicators as inputs, and then you can configure them. We have the indicator parameters here. We have something called depth. So if you set depth to anything greater than 1, it's going to create multiple inputs for that indicator. So the first input will be the indicator value on the current bar, and then the second will be 1 bar ago, and then 2 bars ago. So it's going to let you analyze like a whole sequence of data from one indicator in one item here. So we're just going to leave this at 1. Sorry, go ahead.
Yeah, and you're using it to predict tomorrow's day.
Yeah, so I'm going to use the current day of the week. So I changed the indicator from RSI to day of week. And then I'm going to change the depth to 1 because we don't need to look further back than 1 day. So now I've set that. And let me go ahead and load in some sample data here for the training. I'm going to load in SPY, and I've loaded all SPY data. You can change the data range here. And then you configure how much of the data you want in sample and then out of sample. So I've got 6,400 bars of SPY in sample and then 1,600 out of sample. So now if I go back to my architecture, I should be able to see the minimum, maximum, the mean, and the standard deviation of our day of the week indicator. So that's right on the money. It goes from 1 to 5. So what do we want to predict? That's our input. The output, we are going to predict the day of the week, but we're going to look ahead 1 bar. So we're going to predict the day of the week 1 bar into the future. So should we take a look here at our hidden layers? So these different learning engines, some of them will allow you to add hidden layers to the model. So in a neural network, you have the input layer, you have 1 or more hidden layers, usually, not always, but then you have an output layer. So here I have 1 hidden layer defined, and it has 5 kind of nodes. So the way it works is each input node is going to connect to each of the nodes of the hidden layer, and then each of the nodes of the hidden layer will connect to the output. And then they all have weights and biases that get adjusted during the training. So I think we only need probably 2 nodes in the hidden layer here because it's not a very complicated problem to learn, hopefully. So let's save this. So now we're going to go to parameters. We see we have a bunch of parameters here for NCOG. So each of the learning engines can expose its own set of parameters. So this is fully, configurable by the learning engine. So if we look at a torch sharp model, you see that it has like many more parameters there. So let's go back to our NCOG. And let's go to train and let's start training it. And let's see what happens here. Maybe I'll move this window over a little bit to get it visible with my face here on the bottom. All right, so let's click the start training. And you can see it's moving downward, which is good. The upper graph is the in sample, the lower graph is the out of sample. So as it's training, it also does out of sample evaluations. So the left graphs are epoch by epoch. So each training interval is called 1 epoch. And then the graphs here on the right are every 100 epochs. So you could see, a longer term training result here. And so this will keep going, and I have it configured to automatically stop after there are 10,000 epochs that we have not seen a better out of sample result. So that's good because it'll stop training the model as soon as the out of sample results stop improving. So it winds up saving the snapshot of the model that kind of has the best out of sample performance. So it's saving it before it's like over optimizing basically. And I see now that the range of improvement is like very small here in these graphs. So it may just kind of keep going down like that for a long time. So I'm just going to stop the training. All right, so I stopped the training here. We have an evaluation graph, which is only going to show like a few results because, we this day of the week only goes from 1 to 5. But what it's showing us is that when it predicts when the model predicts a result from one, so basically day of the week one. We have this many counts where that occurred. Then we have the actual average value because it's trained. This is the in sample result. Then we have the out of sample. So this is the predicted out of sample value. So we see that it's lining up very well, basically. So that's telling us that it learned the result. So if I go to chart and I put SPY in here, we can see that this predicted output is ranging from, like if we round the number, like it's giving us like some decimals here, but if we round it, so this would be 1, and then this would be 2, this would be 3, this would be 4, and this would be rounded to 5. So it's predicting what the next day of the week is going to be. So let's see if we drop in the day of the week indicator. I'm going to offset day of the week. So we're going to offset it by -1. So this is going to show us the next bar's day of the week in this blue indicator here. And let's put it in the DL predictor pane. So there we go. You see how this is lining up now? So our predicted day of the week is most of the time matching the actual. I mean, there could be times like this one where we had a weekend where the predicted day of the week was 4, but the actual was 5. So, I mean, if we add more inputs, like maybe kind of the month of the year and things like that, to allow it to predict the calendar, maybe it would be able to learn, that this was a weekend. But I mean, you could see that the model learned how to predict the future day of the week. So that's kind of the basis of training it. So maybe we do something more interesting. You guys have any ideas? I mean, usually what I've been doing, let's create a new one called demo. And let's try using the Torch Sharp learning engine this time. So we can go to our demo architecture. So the default kind of thing we have here is a RSI 4 with a depth of 5, and then we're predicting rate of change after 4 bars with a 4-bar look ahead. So we're predicting the return after 4 bars. Do you guys want to throw in any other indicators or change the output in any way?
Well, let's see. How about let's put a rate of change in there too, so we know which way the price is going.
All right, let's throw in a rate of change.
Yeah.
So what kind of period do we want? I mean, if we're predicting like a short term,
just I would say 2 or 3 days. I mean, nothing, something short. Yeah, just to kind of give you an idea of which way, it's going.
All right, so let's say 3. So, do you want to increase the depth?
Sure. Nope.
No. Okay. Do you want to remove the depth on this RSI? Do you want to bring it down to 1?
Yeah.
All right, so we'll be testing. So far, we only have 2 inputs here, as you can see here, 2 inputs.
How about
we have 1 output.
See, what I still like to do, put something to make it more in context too. Let's see. So we have the rate of change.
I think it's good enough here, just giving an example.
I think, I don't know, like an MACD or something would be good.
All right.
One more, yeah.
So let's throw in the MACD with the standard parameters.
Or actually the histogram probably better.
All right, we can configure that.
Yeah.
MACD histogram.
Yeah, that sounds good.
So we've got our values here: minimum, maximum, standard deviation. Volker, what do you want to throw in?
I think everything is good.
Yeah, I should note that you could use something like the indicator profiler extension to give you an idea of which indicators really work well. So,
Wow.
but that's
I
something.
mean, we're still, Dion, because we haven't seen this, but I mean, basically with NeuroLab, you typically want to work with bounded indicators. Is that kind of the same idea still?
Well, I mean, it will normalize the data, but yeah, I think it tends to work better with bounded indicators,
Okay.
because then if you're running something out of sample and your out of sample indicator is not within the bounds,
Mm-hmm.
that you trained with, it may kind of confuse it a little bit.
So there is a normalization process for these indicators, like
Yeah, these neural
Okay.
networks, depending on the activation function that you select here, it'll use a different normalization. It'll either normalize -1 to 1 or 0 to 1, or it'll use a standard deviation kind of normalization, and that's all handled by the learning engine.
Okay, and these parameters are kind of set to a good default starting point, or how can we learn more about those
Yeah,
parameters?
the parameters are set to a good starting point. You can learn more about them in the help. So we have a section of help on the parameters, and you could also then click on the Torch Sharp link here, which gives much more detail, like on all of these parameters. But yeah, they're set at a decent default settings.
Okay.
So Volker, what did you want to throw in?
Yeah, I was wondering if I throw in a moving average, will it then say, okay, does the AI then look at, is it above or below, or is it,
Well,
we don't know what?
That's kind of what the
MACD is doing, yeah.
Yeah.
And Robert mentioned the rate of change as well, which I would have thrown in as well. So I think we're good.
What about IBS?
Yeah, we can put in the IBS. They all pretty much, IBS is always cool.
And you
Love it.
You like a period of 1, right?
Yep, that's the best one.
All right. So we've got our.
I wonder. I'm actually wondering now, since we just talked about it in before that, whether the IBS would have bought the TTD after that huge gap. I didn't look it up, but I will do it while you run it. I'll check it out.
All right. So should we train this then?
Yeah, train
since
it.
we have 4 input nodes, I think I'm going to reduce this to 3. I mean, I think generally you like to have the number of hidden nodes a little bit less than the number of inputs. So let's try that. Let's save it. And then let's train it on, you want to train it on SPY again?
Yeah.
All right. So let's start training.
Well, it came down
So notice
quick.
how the in sample now is going down and the out of sample is going up.
Mm.
So it's going to stop after a while now, automatically. So it automatically stopped, and it saved the model as of Epic 500. So in Epic 500, that was like the best, kind of point where the out of sample kind of made any sense here. So let's look at the evaluation graph. So as we kind of scroll down, we see near the bottom ranges, we have kind of more red bars, which is good because when the model is predicting a lower rate of change, then the actual rate of change is low, of course, in sample. And then also we have some red bars here out of sample. As we go down, and we see more green bars coming here in sample. We also see more green bars coming here out of sample. So it tells me that it was able to learn something about those relationships, even in out of sample data. So let me delete this day of week here. So now what we wind up with is this DL predictor indicator. And so on any given bar, it's predicting what the rate of change 4 bars in the future will be. So you can see how when things are going down heavily, this indicator is ticking up because it's learned that the market often rebounds strongly
Mhm.
from these sharp down moves after 4 days. So we now have a trained predictor
Mhm.
indicator based on our inputs and the neural net that we trained it with. And you can see if it's even predicting negative rates of change here when SPY is like shooting up like this. So
Mhm.
pretty interesting, huh?
Yeah. And so
It
to put it all
is.
together, you can this is an indicator, so you can put it into a block
Yep.
rule.
Yeah. So we have now just a new indicator in this extension, just like it was in NeuroLab, but we now call this DL predictor, deep learning predictor, and you could use this in any block strategy. Uh, so yeah,
This one already looks good.
yep.
I mean, it
So
looks like it's hitting highs and lows.
yeah, I have some ideas to take this further. So my idea for maybe a next project is maybe building. I mean, now we have games that basically, chess or Go or, any strategy game now can have an AI that can beat any human player, including Dominion, one of my favorite card games, now has a hard AI that's like, I can only beat it maybe 1 out of 10 times. It's just nuts.
Hmm.
So maybe we can train an AI using kind of the way they do it is they just have these AIs playing like against each other and then
Hmm.
just keeping, whichever generation, kind of won the game. So maybe we could do something similar, create like a crucible of these, models that are slowly mutating over time, and the predicted output would just be when to buy and when to sell.
Hmm. Interesting.
I mean, right now we're predicting, like an output of like an indicator. What if the output was actually when should I buy, when should I sell? Could be
Right, because as a condition, we'd have to say, okay, we'd have to pick the value, right? We'd have to say when the
right,
DL predictor
right.
gets to zero 0.9 or when it crosses below from above to 0.9, then buy. So you're saying, tell us what the value is, the kind
Well,
of
yeah,
optimum
I'm
value.
saying, train a strategy using,
Mhm. Mhm.
these neural networks to learn like when to buy and when to sell just based on the historical data.
Okay.
Well, what about if you use this indicator inside your AI? So the AI is using the indicator that it created earlier.
You just blew my mind, Volker. But yeah,
I mean, I'm
what?
just this is going totally. I mean, I'm looking at this chart right now, and I see. I mean, the buy in August. I think it's August 24. I mean, it's like a call, right? I mean,
Yeah, and
it's
this is out of sample. So yeah, this period was out of sample for the training. So yeah, I mean this machine learning, has proven its value. So yeah, let's see where else we can take it.
yeah. Here's another idea that I have, and I look at it. It's just like because it seems to catch things. Like if it is, I think it is around 1 when it was just like getting somewhere. So I'm thinking, what if we can use that indicator to basically increase and decrease the position? Let's say at 1 you buy
Hmm.
100%, and if it goes down, you reduce your position, and it's like pretty. I
Yep.
don't know whether we can actually do that in WealthLab now with any indicator, but I think it would be interesting.
Yeah, yeah, definitely. All right. Well, I think that about summarizes it. So, WealthLab Deep Learning is now available on our extensions page. And if you're a premium WealthLab 8 subscriber, it's yours as part of the premium subscription. Otherwise, it's 99.95, which is a total steal. Why are we pricing things so inexpensively?
I don't know. This one should be more.
This one should be definitely more.
Bravo, bravo,
Oh,
bravo,
bravo.
bravo.
All right. Well, yep. Thank you. And let's see what we can do in the future with this machine learning.
Yeah, I'm looking forward.
All right. Bye.
Bye.